Why is it when you're not playing, you don't fly?
Well, you'll find out. Okay. I'm waiting again. So balanced forces. Okay, so balanced forces is just what it says on the tin. They're when two forces of equal size acting opposite directions. So you see that diagram there, you've got a rectangle or block, and there's 4 newtons pulling it that way and 4 newtons pulling it that way. So that means the forces are balanced, they're equal on either side. Okay? And the effect on the object is as if there is no force at all acting on the object. Okay? And another way of describing that is to say the resultant force is 0. So basically what's happening is we've got plus 4 and we've got minus 4. So they cancel each other out and we end up with 0. Okay? So we've got balanced forces, the resultant force is 0. And Newton's first law is all about balanced forces. Okay, so Newton's first law. Motion has always intrigued scientists, and they've tried to answer the question of how and why things move. The Greek philosopher Aristotle, who lived a long time ago in 350 BC, studied motion and said that for something to move, it must have a force to push or pull it along. At first sight, this idea sounds correct until you think about situations like when a stone is thrown in the air. How does the stone keep moving once it has left the thrower's hand? There's no longer anything pushing it, but it still moves through the air. And Galileo Galilei, yeah, he was born in Pisa a bit later on, so in 1564, and he studied motion, and in one experiment was observing spheres running down a slope and then up another slope directly opposite the first. So like that diagram there. He noticed that a sphere raced from point A always ran up the opposite slope and stopped at nearly the same height as its starting point. So B, C, or D. Just leave it. Galileo then suggested that if there was no opposite slope, such as point E, that the ball would keep moving forever. So thus, a body would keep moving without being pushed or pulled. And this idea was not fully accepted at the time of his death. In the same year, Isaac Newton was born in Lincolnshire, and he became a respected scientist and philosopher. And in part of his studies, he continued and expanded on the work first started by Galileo. He expressed his ideas about force and motion in a statement which we now call his first law of motion. So this bold part here is Newton's first law of motion. Okay, let's call it N1. And it is a body will remain at rest or move at a constant speed in a straight line unless acted upon by an unbalanced force. In other words, if something has balanced forces, or resultant force of 0, it will either be stationary or moving at a constant speed. Okay? So one of those two if the forces are balanced. And what Newton realised that Aristotle did not is that in most real situations, moving objects are acted upon by friction. Therefore, the force Aristotle thought necessary to cause motion is actually only required to balance out or compensate for friction. If there's no friction, as in the vacuum of space, moving bodies will just continue to move. They won't stop. Okay. So, some examples of Newton's first law of motion. So, a car travelling at constant speed. Okay, if something is travelling at a constant speed, it means the forces are balanced. Okay, really important to remember that. So, if a car is travelling at constant speed, then the force of the engine forwards will be equal to the frictional forces backwards. Okay, so the balanced forces means it's a constant speed or stationary. Yeah. A spacecraft moving in deep space, so for example, in the vacuum of space, there's no air resistance to oppose the motion of a spacecraft. Once the vehicle's moving, its engines can be switched off, since the vehicles will continue to move at a constant speed in a straight line. The third one, a passenger standing on a bus or a train when the vehicle starts to move. So I'm sure you've all been on a bus or a train at some point, and so when the vehicle starts to move forwards, if you're just standing there and then the train or the bus moves forwards, you sort of appear to fall backwards, okay? And that's because your body is obeying Newton's first law of motion by remaining at rest, but your feet are dragged forward because there's friction between the floor and your feet. So your feet sort of move forward, but you're sort of staying still. So if your feet move forward from underneath you, you go backwards. And seatbelts. So if a motorist brakes sharply while the car is travelling at, say, 20 metres per second, the braking force only acts on the car. So the car will brake, James, but the person or people inside the car will not brake unless there's something to stop them. So if you don't have a seatbelt on, then the car is going forward quickly, it brakes very quickly, but you are in the car and you continue to go forward through the windscreen, okay? So that's why seatbelts are there. Seatbelts are attached to the car, so they stop you from going forward. They stop you going through the windscreen. So if a motorist brakes sharply while the car is travelling, the brake force only acts on the car. Any object which is not attached to the car will continue to move forward, according to Newton's first law, until it hits the part of the car in front of it. The driver or a front seat passenger may hit the dashboard, steering wheel, or car windscreen unless they're wearing a seatbelt. Seatbelts provide a braking force to oppose the forward motion of people in the car. And the tendency of an object to remain at rest or to continue its motion at constant speed in a straight line is called something called inertia. Okay, so that is Newton's first law. The basics of Newton's first law is really easy, is if something is travelling at a constant speed, the forces are balanced. If something is stationary, the forces are balanced. If the forces are balanced, it's either stationary or moving at a constant speed. That's all you need to know about Newton's first law. All you need to remember is that balanced forces, constant speed, balanced forces. Okay? So I want you to have a go at some questions on this. A lot of people overthink these questions, so try not to overthink them because they are relatively straightforward. If you keep that balanced forces, constant speed, balanced forces in your head. So what I'd like you to do is have a go at some questions on page 4 and 5, please. All right. Hold a bit. Oh, yeah. Completely forgot we forgot.